The wind that swept across the southern Ural Mountains in the late autumn of 1941 did not feel like weather. It felt like a weapon. At a sprawling rail siding on the outskirts of Chelyabinsk, the temperature had already plummeted to 40 degrees below zero. The air was so cold that it burned the lungs of the men and women standing on the platform. Under the harsh and flickering glare of portable electric floodlights, a massive steam locomotive hissed and groaned. Its steel wheels slipped on the icy tracks before finding purchase and shunting backward with a deafening metallic crash. The train was not carrying infantry reinforcements or crates of ammunition for the front lines. It was carrying the heart of a nation's heavy industry. Flatbed cars stretched back into the darkness as far as the eye could see. They were loaded with the sleeping giants of the 20th century. There were massive hydraulic presses capable of crushing steel ingots. There were precision industrial lathes wrapped in canvas and greased paper. There were crates of optical glass and boxes of tungsten carbide tooling. Hundreds of workers huddled in mismatched wool coats and heavy sheepskins jumped from the cattle cars onto the frozen ground. They did not wait for cranes or forklifts. They used ropes and wooden ramps and raw desperation to slide the heavy machinery down into the snow. There were no factory walls waiting for them. There was only a foundation of frozen mud and a mandate from Moscow to begin production immediately. This was the chaotic and violent birth of Tankograd. To understand the sheer improbability of this moment, one must look back to the catastrophic summer that preceded it. In June of that year, the German Wehrmacht had launched Operation Barbarossa, the invasion of the Soviet Union. The advance was swift and devastating. The German armored divisions sliced through the Soviet defenses with a speed that shocked military planners around the world. Within weeks, the industrial heartlands of Ukraine and Western Russia were directly in the path of the Blitzkrieg. The Kharkov locomotive factory, which was the birthplace of the T-34 tank, and the Kirov plant in Leningrad were in imminent danger of capture. In any other conflict, the loss of such critical facilities would have signaled the end of organized resistance. Heavy manufacturing is usually static. It is rooted in concrete and geography. The idea of moving a foundry is as absurd as the idea of moving a mountain. Yet the Soviet leadership made a decision that remains unparalleled in the history of logistics and engineering. They ordered the total evacuation of the industrial base of the Western Soviet Union. It was an endeavor of biblical scale involving the movement of entire cities and populations. Over 1,500 major industrial enterprises were ordered to dismantle their equipment, bolt by bolt. Millions of tons of precision machinery and millions of skilled workers were loaded onto thousands of freight trains and moved east behind the natural fortress of the Ural Mountains. This was not a retreat. It was a migration of the means of production. The journey to the Urals was a nightmare of logistics and endurance. The rail lines were clogged with a chaotic mix of military traffic heading west and industrial traffic heading east. These trains were known as echelons. They moved at a crawl, often stopping for hours in the middle of the desolate steppe to let troop transports pass. The workers riding in the cattle cars had little food and often no heat. They guarded the machines with their lives. Engineers slept curled up next to the lathes they had operated for 20 years, terrified that a sudden stop or a derailment would damage the alignment of the tool. German Luftwaffe bombers hunted these trains relentlessly in the early weeks of the evacuation, turning railheads into twisted graveyards of burning steel and timber. But the trains kept moving. They moved through the autumn rains that turned the roads to mud, and they moved into the teeth of the Russian winter. The destination for a significant portion of this industrial river was the city of Chelyabinsk. Before the war, Chelyabinsk was already a center of industry home to a massive tractor plant that had been built during the rapid industrialization of the 1930s. But the existing facilities were nowhere near large enough to absorb the influx. The Chelyabinsk tractor plant was about to absorb the equipment and personnel. From the Kirov plant in Leningrad, the Kharkov diesel engine works, and several other smaller suppliers, the merger of these industrial giants created a super complex that the world had never seen before. The locals called it the Chelyabinsk-Kirov plant. The workers and eventually the intelligence agencies of the world simply called it Tankograd. The arrival at the site was a scene of organized bedlam. The rail siding was a bottleneck of steam and shouting. Valuable milling machines sat in the open fields buried under snowdrifts for weeks because there was simply nowhere to put them. Logistics officers shouted over the wind trying to match crates of parts with the correct assembly teams. The snow was waist-deep in places hiding the frozen earth, where the new assembly lines were supposed to go. There was no time to build buildings. The standard sequence of construction, excavation, foundation, walls, roof, and then equipment installation, was abandoned entirely. The directive from the State Defense Committee was clear. The front line needed tanks, and it needed them now. Engineers cleared the snow from the concrete foundations of the existing tractor factory yards and bolted the evacuating heavy machinery directly to the floor exposed to the sky. In those first desperate weeks, the factory was essentially an open-air workshop, operating in sub-Arctic conditions. Snow fell on the hot steel of the casting molds, causing steam to billow up and obscure the vision of the crane operators. Lubricating oil froze solid in the hydraulic lines of the presses and had to be heated with open flame torches before the machines could cycle. Men and women worked with frost-bitten fingers, handling metal that was so cold it could strip the skin from a hand if touched without heavy gloves. The electrical grid was a patchwork of improvisation. Heavy cables were strung up on temporary wooden poles that swayed in the blizzard winds. The current flickered constantly as the load of hundreds of new machines stressed the local power plant to its breaking point. When the lights failed, the workers continued by the light of kerosene lanterns and bonfires fed with scrap wood and coal. The shadows danced across the half-assembled hulls of tanks, creating a surreal and gothic atmosphere. This was industrial primalism. The sophisticated heavy industry of the 20th century was being conducted with the brute force of the Bronze Age. The workforce slept where they could. Many of the evacuees had arrived with nothing but the clothes on their backs. There was no housing for the thousands of new arrivals. They dug zemlyankas or earth dugouts into the frozen ground near the factory perimeter. These were essentially holes in the earth roofed with logs and sod heated by small stoves. Others slept on the floor of the workshops between the machines, soaking up the residual heat of the engines. The line between life and work had been erased. The factory was their home, and the factory was their battlefield. One of the most critical challenges in these early days was the reassembly of the massive vertical boring mills used to machine the turret rings. These machines were 2 stories tall and required precise leveling. Installing them on frozen ground that shifted as the heat from the factory melted the permafrost was an engineering nightmare. Surveyors worked around the clock, constantly measuring the tilt of the foundations and shimming the massive machines to keep them true. If the turret ring was off by even a fraction of a degree, the turret would jam in combat, essentially turning the tank into a useless steel coffin. The sound of the site was unique. It was a cacophony that never ceased. The shriek of train whistles brought more raw steel and more coal every hour. The ground shook with the rhythmic pounding of the steam hammers forging crankshafts. Over it all was the roar of the wind coming off the Ural peaks. It was a place of sensory overload, where the smell of ozone from welding arcs mixed with the acrid smoke of coal fires and the exhaust of diesel engines. The psychological pressure on the leadership of the plant was immense. Isaac Zaltzman, the man appointed to run the facility, was known as the Tank King. He was a ruthless administrator who carried a pistol and was known to fire managers on the spot for delays. He understood the binary nature of their reality. If they produced tanks, the Red Army might hold. If they failed, the Germans would eventually cross the Volga and the war would be lost. Zaltzman walked the freezing factory floor, constantly checking the quotas, pushing the exhausted workforce to find one more gear. As the winter deepened, the conditions worsened. The food supply was precarious. The cafeteria served a watery millet soup and blocks of heavy black bread. Scurvy and typhus began to appear among the workers. Yet the work did not stop. The first T-34 tanks to roll out of Tankograd in this period were rough beasts. They were assembled by freezing hands and tested on icy tracks. They were not pretty machines, but as the engines roared to life, coughing black smoke into the white air, they represented a miracle. The industry of the Soviet Union had not died on the rail lines. It had transplanted itself and taken root in the frozen earth. The exodus was complete. Now the war of production would truly begin. The machinery that had been dragged from the rail cars and bolted to the frozen earth was impressive, but it was useless without a pulse. The great hydraulic presses and the towering steam hammers were merely cold iron. To turn them into a weapon of war required a workforce of unprecedented scale and resilience. The population of Tankograd became a mirror image of the Soviet Union itself during its darkest hour. It was a demographic upheaval where the traditional roles of society were not just bent, but shattered entirely. The initial wave of personnel that arrived with the evacuated equipment included the elite industrial class of the Soviet Union. These were the master machinists from Leningrad and the diesel engineers from Kharkov. They were men who could listen to the rhythm of a crankshaft and diagnose a microscopic fracture by sound alone. They were the brain trust and the keepers of the institutional knowledge that kept the assembly lines moving. However, there was simply not enough of them. The voracious appetite of the expanding factory complex required tens of thousands of hands, and the vast majority of the nation's able-bodied men had been consumed by the front lines. The Red Army was fighting a desperate delaying action hundreds of miles to the west, and it demanded every man who could hold a rifle. To fill the void on the assembly floor, the factory managers turned to those who had been left behind. The mobilization of the workforce was total. Women who had previously worked as teachers or seamstresses or farm laborers were drafted into heavy industry. They stepped out of domestic lives and into the inferno of the foundry. Within months, women made up a massive percentage of the workforce at Tankograd. They were not relegated to administrative tasks or light assembly. They operated the massive overhead cranes that swung 10-ton tank hulls through the smoky air. They stood in the pits of the forge, handling white-hot ingots with long iron tongs. Photographs and newsreels from the era capture this transformation with striking clarity. They show lines of women wearing heavy quilted jackets known as telogreikas. Their heads are wrapped in thick scarves to protect against the sparks and the cold. Their faces are often smudged with grease and soot, and their expressions are hard. There is no smiling for the camera. These women became expert welders. The T-34 required miles of welding seams to seal its hull and turret. It was back-breaking work that required a steady hand while holding a heavy torch for 12 hours at a time. The women of Tankograd learned to lay beads of molten steel that were strong enough to withstand the impact of German anti-tank shells. They did this while standing on concrete floors that were covered in ice, working in air that was thick with metal dust. The other major component of this improvised industrial army was the youth. The Soviet Union utilized a system known as the FZO, or Factory Apprenticeship Schools, to mobilize teenagers and children. It was not uncommon to walk down a row of milling machines in 1942 and see operators who were barely 12 or 13 years old. These children were too short to reach the controls of the heavy industrial equipment that had been designed for adult men. The solution was crude but effective. The factory carpenters built thousands of wooden crates and boxes. The children stood on these boxes so they could see into the cutting area of the lathes. The loss of childhood in Tankograd was absolute. These boys and girls worked shifts that paralleled the adults, often stretching to 12 or 14 hours a day. They lived in a state of perpetual exhaustion. There are accounts of foremen walking the lines and gently waking children who had fallen asleep, leaning against their machines during a brief lull in the supply of parts. They were not punished. They were simply woken up and told to continue. The survival of the nation depended on the output of that machine, and the child knew it as well as the foreman. The conditions under which this patchwork army lived and worked were grueling beyond modern comprehension. The rapid expansion of the workforce had completely overwhelmed the local housing infrastructure. Barracks were built hastily using green timber that warped in the wind. Inside these long wooden structures, rows of bunk beds were packed so tightly that there was barely room to walk between them. The heat came from small cast-iron stoves that burned constantly, but could never truly banish the Siberian chill. In the mornings, the workers would wake up to find frost on the inside of the walls. Food was fuel, and fuel was scarce. The rationing system was strict and unforgiving. The staple of the diet was a dense black bread that was often frozen solid when it was handed out. Workers carried it inside their jackets against their bodies to thaw it out before they could eat it. The canteen served a soup called balanda, which was often little more than boiling water with a few cabbage leaves or potato peelings. Protein was a luxury. A piece of salt pork or a tin of American Spam provided by the Lend-Lease convoys was a treasure to be hoarded. Malnutrition was chronic. The physical demands of wrestling steel parts combined with the caloric deficit meant that workers were constantly on the verge of collapse. Safety regulations effectively ceased to exist. In peacetime, a factory is a controlled environment with guardrails and emergency stops and safety inspectors. In Tankograd, the only safety protocol was to keep the line moving. The machinery was packed together tightly to maximize floor space, leaving narrow aisles where workers had to squeeze past spinning flywheels and moving belts. Accidents were frequent and gruesome. A loose sleeve caught in a drill press or a moment of inattention under a suspended load could result in severe injury or death. There were no ambulances waiting. If a worker was injured, they were carried to the infirmary by their comrades, and the machine was wiped down and restarted immediately. The medical staff at the plant dealt with a relentless stream of industrial trauma. They treated crushed fingers and severe burns from welding spatter. They also fought a constant war against typhus and dysentery, which thrived in the crowded, unsanitary conditions of the barracks. Soap was in short supply. Hot water was a luxury. The lice were ubiquitous. Yet, despite the sickness and the danger, the absenteeism rate was incredibly low. This was partly due to the draconian labor laws that had been enacted. Being late for a shift by more than 20 minutes was considered a criminal offense. Unauthorized departure from the factory was treated as desertion in the face of the enemy. The factory was run under martial law. The plant director had the authority of a military commander. But fear of punishment was not the primary motivator. A fierce and grim camaraderie developed on the factory floor. The workers understood the stakes. There was a tangible sense that the factory was connected directly to the front line by an invisible umbilical cord of steel. Every track link cast and every shell casing machined was a life saved on the front. Many of the women working the presses had husbands or sons serving in the Red Army. They received triangular folded letters from the front, often stained with dirt, describing the hell of the battlefield. These letters were read aloud during breaks. They fueled a hatred for the invader that transcended physical exhaustion. The propaganda department plastered the walls of the factory with posters. They depicted the fascist beast being crushed by the red hammer of industry. Loudspeakers blared patriotic songs and news updates about the movements of the armies. But the workers did not need slogans to understand their reality. They saw the broken tanks that were sometimes brought back to the factory for repair. They saw the jagged holes punched through the armor and the scorched interiors. They knew that their work was the only thing standing between their families and extermination. The integration of human life and machine rhythm became total. The factory never slept. It operated 24 hours a day in 2 long shifts. The concept of day and night became irrelevant inside the assembly halls where the arc lights always burned. The noise was a physical weight. The pounding of the drop forges vibrated in the chest cavities of the workers. The screech of metal cutting metal was a constant scream. To a newcomer, the noise was terrifying, but to the veterans of Tankograd, it was the sound of life. Silence was the enemy because silence meant that production had stopped. In this environment, the distinction between the tool and the operator blurred. The workers became components of the assembly process, as vital and as interchangeable as the gears in the transmission. A veteran machinist might collapse from typhus and be replaced within the hour by a teenage apprentice who had barely learned how to read a micrometer. The apprentice would stand on the wooden crate and take up the work. The machine did not care who operated it. It only demanded to be fed raw steel. This was the army of iron and flesh that inhabited Tankograd. It was an army without uniforms or medals. They fought their war with files and wrenches and welding torches. They fought against the cold and the hunger and the overwhelming fatigue. And in doing so, they achieved a rate of production that defied every logic of industrial economics. They were building the instrument of their own salvation, one rough weld at a time. The object of all this suffering and labor was a machine that history often remembers through a lens of romantic invincibility. The T-34 tank is frequently cited as the finest armored vehicle of the Second World War. However, the reality of the machine that rolled out of the freezing workshops of Tankograd was far removed from the polished prototypes that sit in modern museums. The T-34 was not a marvel of fit and finish. It was a marvel of brutal pragmatism. It was a weapon designed not by the vanity of engineers, but by the terrifying necessities of total war. The spiritual father of the T-34 was Mikhail Koshkin, a visionary designer who had died of pneumonia before the German invasion began. Koshkin had fought bitter political battles in the late 1930s to prove that the future of armored warfare lay in mobility and ballistic shape rather than sheer thickness of steel. His team created a hull with sharply sloped armor. The physics were simple but revolutionary. A 45mm plate of steel standing vertically offers 45mm of protection. But if that same plate is angled back at 60 degrees, it presents an effective thickness of nearly 90mm to an incoming horizontal projectile. More importantly, the steep angle increased the likelihood that an enemy shell would simply glance off harmlessly into the sky. This geometry allowed the T-34 to be lighter and faster than its rivals while offering protection comparable to a heavy tank. Under the rear engine deck lay the V2 diesel engine. This was an aluminum block masterpiece that was in many ways far ahead of its time. While German tanks were still using gasoline engines which were prone to catching fire and offered poor fuel economy, the T-34 ran on diesel. The fuel was less volatile and the engine was incredibly efficient, allowing the tank to travel long distances across the vast Russian steppe without refueling. Producing this complex aluminum engine in the chaos of the Urals was a constant challenge that required the highest level of skill available in the plant. The engineers refused to compromise on the power plant because they knew that mobility was the tank's primary defense. However, the realities of Tankograd forced radical changes to almost every other aspect of the design. The philosophy became one of ruthless simplification. The goal was to reduce the number of man-hours required to build each unit and to eliminate any component that relied on scarce materials. The supply lines were constantly disrupted, and the factory could not wait for shipments of specialized parts. They had to improvise. One of the most visible changes involved the road wheels. The original design of the T-34 utilized road wheels rimmed with thick rubber tires to cushion the ride and reduce vibration. But after the invasion, rubber became a critical strategic resource that was in dangerously short supply. The designers at Tankograd were forced to create a new type of wheel made entirely of cast steel. These were known as the spider wheels due to their ribbed reinforcement pattern. The result was a suspension system that was incredibly durable but deafeningly loud. When a T-34 equipped with steel wheels moved at speed, the metal tracks hammering against the metal wheels created a high-pitched ringing sound that could be heard for miles. Inside the tank, the vibration was so intense that it could loosen the fillings in a crewman's teeth. But the steel wheels did not require rubber from the Far East, so they went into production by the thousands. The welding on the T-34 hulls produced in Chelyabinsk became a visual signature of the desperate times. A modern inspector looking at a preserved T-34 from 1942 or 1943 will see welds that look rough and hurried. The beads of filler metal are often uneven. There are splatter marks frozen in the steel where the molten metal splashed and cooled. In some places, the armor plates are slightly misaligned. To a Western eye accustomed to the neat uniform welds of American shipyards or the precision joinery of German factories, it looks like sloppy workmanship. But this assessment misses the point entirely. The welds were structurally sound, the penetration was deep, and the bond was strong. The aesthetic ugliness was a deliberate choice to save time. Every minute spent grinding a weld smooth or polishing a steel plate was a minute the tank was not on a train to the front. The factory managers calculated that cosmetic finishing added absolutely zero combat value. If a part did not affect the mechanical function of the tank or its ability to kill the enemy, it was left rough. The steel was cut with oxyacetylene torches and often left with the jagged slag still attached to the edges. The casting of the turrets was a particularly brutal task that embodied the struggle of the factory. The turrets were cast in massive sand molds. In the drafty factory halls where the temperature fluctuated wildly, the cooling process had to be managed by eye and experience. If the steel cooled too quickly, it would become brittle and crack. If it cooled too slowly, the production line would stall. The workers poured the molten steel into the molds and then monitored the hardening metal amidst the smoke and fumes. The resulting turrets often had a rough, textured surface that looked like orange peel or cast iron cookware. This texture was the imprint of the sand molds. It was not smoothed over. It was simply painted green. The interior of the tank was equally Spartan. There was no padding and no comfort. The driver sat in a cramped compartment surrounded by control levers that required immense physical strength to operate. The transmission of the T-34 was notoriously difficult to shift. It was a simple 4-speed gearbox, but the machining tolerances were loose. It was not uncommon for a driver to keep a heavy sledgehammer next to his seat. When the gears refused to mesh, he would strike the shift lever with the hammer to force it into place. The ventilation was poor. When the main gun fired, the turret would fill with cordite fumes that burned the eyes and throat. But the tank worked. It would start in the freezing Russian winter when German engines were frozen solid blocks of ice. Its wide tracks, which utilized the American-designed Christie suspension system, allowed it to float over deep snow and Rasputitsa mud that bogged down heavier enemy vehicles. This approach represented a fundamental shift in the philosophy of military engineering. The German Wehrmacht viewed a tank as a precision instrument. Their Tiger and Panther tanks were marvels of engineering, with complex interwoven road wheels, comfortable crew compartments, and optics that rivaled laboratory equipment. They were built to last. The Soviets at Tankograd viewed the tank as a consumable munition. It was essentially a shell casing on tracks. The statisticians in Moscow and Chelyabinsk had calculated the life expectancy of a T-34 on the front line. In the height of the fighting in 1942 and 1943, a tank was expected to survive for only a few weeks, often only a few days, or a handful of attacks. There was absolutely no point in building a transmission that would last for 10,000 miles if the tank would likely be destroyed after 200 miles. The goal was to ensure the tank functioned reliably for its short, violent life. This philosophy of quantity has a quality all its own was not an excuse for poor performance. It was a strategic calculation derived from the reality of the Eastern Front. The Germans were building clocks. The Soviets were building sledgehammers. A clock is useless if it loses a single gear. A sledgehammer works even if the handle is chipped and the head is rusted. The T-34 was designed to be fixed in the field by teenage conscripts who had little mechanical training. The loose tolerances meant that parts from one tank could easily be cannibalized and fitted to another. If a track pin snapped, the crew could hammer in a piece of scrap metal to hold it together. This resilience was designed into the machine at the factory level. There were also innovations born of scarcity that improved the tank. When the supply of complex machined air filters ran out, the engineers designed a new type of air cleaner called the cyclone, which used centrifugal force to separate dust from the air. It was simpler to manufacture and easier to clean, and it protected the engine from the pervasive dust of the steppe summers. The design process at Tankograd was fluid. Engineers lived on the factory floor. When a problem arose, they did not send a memo to a distant headquarters. They walked to the station where the bottleneck was happening and sketched a solution on the concrete floor with chalk. If a specific bolt was running out, they redesigned the bracket to use a weld instead. If a certain grade of steel was unavailable for a hatch, they substituted a different alloy and increased the thickness to compensate. The result was a weapon that lacked uniformity. A T-34 produced in January might look slightly different from one produced in March. The shape of the turret might change slightly. The pattern of the handrails might be different, but they all shared the same lethal DNA. They all carried the high-velocity 76mm gun, capable of penetrating German armor. They all moved with the same aggressive agility. As the tanks rolled off the line, they were not subjected to the rigorous long-term testing of peacetime. They were taken to the factory proving ground for a shakedown. They were driven hard over bumps to ensure the suspension didn't collapse, and the gun was fired to ensure the recoil mechanism worked. If it passed this basic check, it was accepted. Often the paint was still tacky and wet as the tank was loaded onto the rail car. The smell of the tank was a mix of diesel fuel fresh paint and the flux from the welding rods. It was the smell of urgent, violent industry. This design philosophy created a machine that was terrifying in its ubiquity. It was not a perfect tank. It was uncomfortable, loud, and dangerous to be inside, but it was available. While the Germans agonized over the production of a few hundred perfect heavy tanks, Tankograd was preparing to flood the world with thousands of good-enough medium tanks. The design of necessity had created a monster that could not be stopped by technical superiority alone. By the beginning of 1943, the industrial landscape of the Urals had undergone a profound transformation. The open-air workshops of the previous winters were gone. They had been enclosed by hasty but solid brick walls and timber roofs that blocked out the biting wind. The snow no longer fell directly onto the lathes, and the assembly lines were no longer illuminated solely by the flickering light of bonfires. Tankograd had evolved from a desperate refugee camp into a hardened and efficient industrial fortress. The chaos of the evacuation had settled into a rhythm of relentless and terrifying productivity. The gamble of moving an entire civilization's industry behind the mountains had begun to pay its dividends in a currency of steel and high explosive. The flow of raw materials into the complex had stabilized. The rail lines that connected Chelyabinsk to the coal mines of the Kuzbass and the iron ore deposits of Magnitogorsk were operating with the precision of a conveyor belt. Trainloads of coal arrived hourly to feed the power plants, which now generated enough electricity to keep the arc welders humming 24 hours a day. The shortages of the early war years had been overcome not by luxury, but by the sheer volume of basic resources. There was enough steel, there was enough coal, and most importantly, there was enough willpower to turn these raw elements into the most produced tank in history. Inside the cavernous assembly halls, the atmosphere had shifted. The frantic improvisation of 1941 had been replaced by a grim, methodical discipline. The assembly process had been broken down into a series of distinct stations. The hull of the tank moved down the line on a heavy dolly, growing in weight and complexity with every stop. At one station, a team of women would lower the V2 diesel engine into the engine bay. At the next, a team of teenagers would bolt the transmission into place. Further down, the massive turret ring was lowered by a crane and seated onto the hull. The synchronization of these tasks was a feat of logistical genius. The factory managers had analyzed every movement and every second. There was no wasted motion. If a worker dropped a wrench, they did not stop to pick it up if it meant slowing the line. They grabbed another wrench and kept working. The output numbers were staggering. While German factories were struggling under the increasing weight of Allied strategic bombing and chronic shortages of rare alloys, Tankograd was expanding its capacity every month. The Germans were still building tanks like artisans, treating each Tiger or Panther as a unique project that required perfect finishing. The Soviets were building tanks like loaves of bread. In the time it took a German factory to finish the complex suspension of a single Tiger tank, Tankograd would roll a dozen T-34s out the door. The disparity was not just in numbers, but in philosophy. The Germans sought tactical superiority through technology. The Soviets sought strategic victory through volume. The final stage of production at Tankograd was a sight of industrial majesty that few Western observers ever witnessed. The assembly line ended at a row of massive bay doors that opened directly onto the factory proving grounds. The tanks did not sit in a warehouse waiting for inspection paperwork or bureaucratic approval. They were fueled up immediately, often, while the paint on the hull was still wet and tacky. The smell of the fresh green paint mixed with the heavy oily scent of diesel fuel created an aroma that permeated the entire district. Crews from the Red Army were often waiting right at the factory gates. These men were tank crews who had lost their vehicles at the front or fresh graduates from the training schools. They would climb into the tanks before the seats had even cooled from the welding torches. They ran the engines up to operating temperature, checked the gun sights, and drove the tanks directly onto the flatbed rail cars waiting at the siding. The turnaround time was practically zero. There were legends in the factory of desperate moments when tanks were driven directly from the yard to the front lines during the critical defense of Moscow, though by 1943 the front had moved far enough west that the rail journey was necessary. The ultimate validation of Tankograd's existence came in the summer of 1943 at the Battle of Kursk. This engagement remains the largest tank battle in human history. The German High Command had gathered their strength for one final decisive blow. They introduced their new heavy armor, including the Tiger and the Panther tanks, which were technologically superior to anything the Soviets possessed. The Tiger had thick frontal armor that the standard T-34 gun could not penetrate at long range, and its 88mm gun could destroy a Soviet tank from over a kilometer away. On paper, the technological mismatch was severe. But war is not fought on paper. It is fought with logistics and attrition. When the German pincers closed around the Kursk salient, they were not met by a thin line of defenders. They were met by an ocean of armor. The Soviet response was to flood the battlefield with the output of the Ural factories. For every T-34 that the German Tigers destroyed, 2 more appeared from the steppe. The sheer density of Soviet armor forced the Germans into close-range engagements where the advantages of their long-range guns were negated. The battle became a grinding industrial slaughter. The T-34 crews knew they were outgunned. Their tactics reflected the desperation and the abundance of their machines. They charged the German heavy tanks at full speed, closing the distance to point-blank range, where their guns could penetrate the side armor of the Tigers. In some cases, when their ammunition was exhausted or their guns were disabled, Soviet commanders ordered their drivers to ram the enemy vehicles. This tactic, known as the Taran, was the ultimate expression of the Soviet war machine. A $45,000 tank produced by the thousands was traded for a sophisticated German machine that took months to build. It was a brutal calculus, but it was effective. The field at Prokhorovka, where the climax of the battle took place, became a graveyard of burning steel. But when the smoke cleared, the the German offensive had been broken. They had lost irreplaceable machines and elite crews. The Soviets had lost far more tanks, but the trains from Chelyabinsk were already arriving with replacements. The losses were absorbed. The gaps in the ranks were filled before the fires in the burning wrecks had even gone out. The German industrial base simply could not compete with the avalanche of steel that was pouring out of the Urals. This victory shifted the psychological momentum of the war. The German soldier looked out across the battlefield and saw an enemy that seemed to have infinite resources. No matter how many tanks they destroyed, the horizon was always filled with more green silhouettes. The realization that they were fighting a losing war of production began to take hold. They were not just fighting the Red Army, they were fighting the entire industrial output of a mobilized continent. Back in Chelyabinsk, the news of the victory at Kursk was broadcast over the factory loudspeakers. The workers paused for a moment to listen, but the machines did not stop. The steam hammers continued to pound, and the conveyors continued to move. There was no celebration in the traditional sense. There was only a grim satisfaction. The workers knew that their labor had saved the nation, but they also knew that the road to Berlin was still long. The quota for the next month was already higher than the last. The success at Kursk also allowed the engineers at Tankograd to finally look beyond immediate survival and consider upgrades. The battlefield reports indicated that the T-34 needed a bigger gun to deal with the German heavy tanks more effectively. This feedback loop led to the development of the T-34-85, which would carry a larger 85mm gun in a new 3-man turret. The design bureaus began to work on this improved model even as the factory continued to churn out the older version. The flexibility of the production line allowed them to prepare for this transition without halting output. The logistics of moving this avalanche of steel west required a transportation network of immense complexity. The Trans-Siberian Railway line became a dedicated artery of war. Trains moved in a solid block, often with only a few hundred yards between the caboose of one train and the engine of the next. They carried tanks on the flatbeds and ammunition in the boxcars. On the return journey, they carried broken tanks to be repaired and scrap metal to be melted down and born again. It was a circulatory system of iron. By late 1943, the Red Army was no longer just holding the line. It was advancing. The tracks of the T-34S were churning up the mud of Ukraine and pushing toward the Polish border. The tanks that were liberating the occupied territories were the children of Tankograd. They bore the rough casting marks of the Ural sand. They rattled with the sound of the steel spider wheels. They were not perfect, but they were victorious. The story of the T-34 in this phase of the war is not just a story of military tactics. It is a story of industrial velocity. The factory at Chelyabinsk had achieved a state of flow where the raw materials of the earth were being converted into combat power at a speed that defied analysis. The Germans had bet on quality and precision. The Soviets had bet on the idea that a good tank today is better than a perfect tank tomorrow. And as the year 1943 came to a close and the Soviet steamroller began to gather unstoppable speed, it became clear that the bet had paid off. The miracle of the evacuation was no longer a desperate act of survival. It had become the foundation of conquest. The factories of the Urals had built a hammer big enough to crush the Third Reich, and they were swinging it with all their might. As the winter of 1944 descended upon the Urals, the atmosphere inside Tankograd had shifted once again. The desperation of the early years had hardened into a cold, professional fury. The factory was no longer just building a shield to protect the motherland. It was forging the hammer that would smash the Third Reich. However, the engineers at Chelyabinsk faced one final titanic challenge. The standard T-34 with its 76mm gun was no longer sufficient. The German heavy tanks had become thicker and deadlier. The Red Army demanded a tank that could not only swarm the enemy, but kill them at long range. they needed the T-34-85. Retooling a massive industrial complex in the middle of a total war is a logistical nightmare that borders on the impossible. In a peacetime economy, a factory would shut down for months to install new jigs, calibrate new tools, and retrain the workforce. Tankograd did not have that luxury. Production could not stop for a single hour. The transition to the new model had to happen while the assembly line was still moving. This phase of production required a level of coordination that rivaled a ballet. The new tank required a larger turret ring, which meant the hull itself had to be modified. The turret was a massive 3-man cast steel design that was significantly heavier than the original. To accommodate this, the factory engineers had to redesign the machining stations overnight. They worked in shifts that blurred into days, sketching modifications on scrap paper and implementing them immediately. The first T-34-85S rolled down the line, mixed in with the older models. It was a chaotic stream of armor where the past and the future of the tank moved side by side until the new design completely took over. The workers, who were now veterans of 3 years of industrial warfare, adapted with remarkable speed. The teenage boys who had stood on crates in 1941 were now young men who handled their machines with the casual confidence of master craftsmen. The women who had learned to weld under the open sky were now the backbone of the most productive tank plant in the world. They adjusted their torches for the thicker armor of the new turrets without complaint. The quota remained the absolute law. By the spring of 1944, the fruits of this labor were flooding into Eastern Europe. The Operation Bagration offensive, which shattered the German army group. Center was fueled by the diesel that flowed from the Urals. The T-34-85S were everywhere. They moved in columns that stretched from horizon to horizon, kicking up clouds of dust that choked the retreating German infantry. The tanks were no longer just fighting vehicles. They had become the primary mode of transport for the Red Army. Infantry units known as Tankodesantniki rode on the back of the engine decks, holding on to the rough, welded handrails that had been attached specifically for them in Chelyabinsk. The durability of the machines was tested to the limit during the race to the west. The tanks were driven for hundreds of miles without maintenance. The tracks rattled and the engines leaked oil, but they kept moving. When a tank broke down, it was often repaired on the side of the road using a sledgehammer and a wrench. The loose tolerances that Western engineers mocked were the very thing that allowed a muddy, exhausted crew to force a replacement part into place and get back into the fight. The tank was not a delicate instrument. It was a tractor for war, and it treated the battlefield with the same brute force that a plow treats a field. The climax of the Tankograd story arrived in April 1945. The setting was the ruined streets of Berlin. The city had been turned into a fortress of concrete and rubble, but it was no match for the industrial output of the Soviet Union. The T-34S that rumbled over the cobblestones of the German capital were the physical manifestation of the Ural miracle. They were painted in dark green, often covered in slogans hand-painted in white wash by the crews. For the motherland, or for Stalin, or simply, to Berlin. In the chaotic urban combat of Berlin, the rough casting of the turrets and the unpolished welds proved their worth. The tanks took hits from Panzerfausts and anti-tank guns. Many burned. The streets were littered with the twisted metal of the T-34S. But for every tank that was destroyed, there was another one right behind it. The sheer volume of armor was overwhelming. The German defenders were not defeated by a superior tactic. They were buried under an avalanche of steel that had been dug out of the ground in Magnitogorsk and cast in the fires of Chelyabinsk. When the red flag was finally raised over the Reichstag, it marked the end of the war in Europe, but it did not mark the end of the T-34. The legacy of the tank and the factory that built it was only just beginning. As the guns fell silent, the tanks did not simply rust away. They became the symbol of Soviet power. They were mounted on concrete plinths in liberated cities across Eastern Europe, serving as permanent reminders of who had driven out the fascists. In the years that followed, the T-34 became the Kalashnikov of tanks. It was exported to dozens of countries. It saw combat in the Korean War, where it initially dominated the battlefield. It fought in the deserts of the Middle East and the jungles of Vietnam. The simple, rugged design that allowed it to be built by semi-skilled labor in freezing conditions also made it the perfect weapon for developing nations and revolutionary movements. It was easy to operate, easy to fix, and incredibly difficult to kill. Even today, in remote corners of the world, one can still find T-34s that are mechanically operational, running on the same basic diesel engine design that was perfected in the evacuation of 1941. Back in Chelyabinsk, the end of the war brought a strange silence to the factory. The frantic pace of the emergency years slowed. The lights were turned off at night for the first time in 4 years. The Tankograd moniker officially faded, and the facility returned to its original name, the Chelyabinsk tractor plant. The focus shifted from tanks back to the heavy agricultural tractors needed to rebuild the shattered Soviet agriculture. The massive presses that had stamped out turret roofs began to stamp out hoods for farm equipment. However, the factory was changed forever. It retained a dual nature. While one assembly line built tractors, another secret line continued to develop the next generation of armored vehicles. The lessons learned in the blood and cold of the war were applied to the heavy tanks of the Cold War, like the IS series, and eventually the T-72. The culture of the plant remained one of heavy metal resilience. The human cost of the industrial miracle was never fully tallied. There are no precise records of how many workers died of typhus malnutrition or industrial accidents during the war years. They were buried in mass graves in the frozen earth, often without markers. The Soviet state celebrated the production numbers, but rarely dwelt on the individual suffering that made those numbers possible. The women who had ruined their backs lifting artillery shells, and the children who had inhaled metal dust for 12 hours a day simply went back to their lives. They were the anonymous soldiers of the rear front. Today, visiting Chelyabinsk feels like stepping into a cathedral of heavy industry. The city is still dominated by the massive footprint of the tractor plant. Monuments to the war years are everywhere. In Victory Park stands a pristine T-34 on a pedestal. Its barrel points west toward the front line that no longer exists. If you look closely at the tank, you can see the texture of the turret. It is rough and pitted like the skin of an orange. You can see the welds that join the armor plates, thick and slightly uneven, laid down by a hand that might have been shaking from cold or fatigue. These imperfections are the true story of the tank. They are the fingerprints of history. They tell the story of a time when a factory was dropped into the snow and told to save the world. They tell the story of the expansion gaps in human endurance. The T-34 was not a miracle of divine intervention. It was a miracle of human will. It was the product of a desperate gamble that paid off in the only currency that mattered: survival. The story of Tankograd is a testament to the terrifying capability of an industrialized nation when it is pushed to the brink of extinction. It proved that in the calculus of total war, the most beautiful weapon is not the one with the finest engineering or the most advanced technology. The most beautiful weapon is the one that works. And the T-34 worked. It worked in the snow. It worked in the mud. And ultimately it worked in the ruins of Berlin.